Now, the first step is head over to the course resources list and head over to the skeleton project on GitHub. Now, this skeleton project doesn't have any code in it, and it only has the bare bones storyboard design. So go ahead and git clone or download and unzip this project and open it inside Xcode 10. Now, you can see that all we have on screen is just a simple app with a single label that is the sentiment label, as well as a text field and a prediction button. And those are linked up as two IB outlets for the text field and the sentiment label, and one IB action for when the user presses the predict button. That's all I've placed inside the skeleton project. So once we're ready with that, we can actually go ahead and close it down, because we need to first build our machine learning model that is going to do the sentiment analysis. Now, in order to build any machine learning model, we're going to need some data. So you can download the Twitter sentiment data inside the course resources list as well. There is the download link here. And if you click on it, download should start automatically. And make sure that you unzip that file so that you end up with a CSV. Now, this public data set comes from a company called Sanders Analysis. And at one point, they collected 1,000 tweets that mentioned the AAPL, so the Apple stock, or the @Apple handle. And then they employed a bunch of people, humans, to read through each of the tweets and give it a rating of positive, negative, or neutral. So let's take a look at this data and see what it looks like. So I want you to head over to Google Sheets and create a brand new spreadsheet. Now, in this spreadsheet, you're going to open up that CSV file by uploading that CSV file that you just downloaded and extracted. So this is what our data looks like. If you scroll down, you can see that there are around 1,000 tweets, and they were found by searching for the handle @Apple. So when somebody is mentioning the Apple brand, basically. And then humans have read through all of these, some sensical, some nonsensical tweets to rate it, whether it's positive, negative, or neutral. And this is the point where we can be grateful that we didn't have to do what we did in previous modules to use CreateML, which is generating our own data. I'm pretty sure this would take us days to trawl through Twitter, download the tweets relevant to Apple, and then read through them individually and specify whether if it's neutral, positive, or negative. So here we have our data. So the next thing we need to do is to use it to create our machine learning model, so that our model learns what positive tweets look like, what neutral tweets look like, and what negative tweets look like. So we can use it to analyze future tweets that it's never seen, that don't exist over here. So as we did previously, in order to use CreateML to generate our machine learning model, we're going to use a Mac OS blank playground. And I'm just going to save it on my desktop, and I'm going to call it Tweet Sentiment Model Maker. Now, unfortunately, unlike the image recognition builder, there is no live view for creating natural language processing models yet. But that's not a problem. All we have to do is just write a few lines of code in order to load up our data and get CreateML to start working on it. Now, the first thing that we're going to do is we're going to delete this variable string, but we're going to keep our Cocoa framework imported. And in addition, we're going to import, of course, CreateML in order to use it to create our machine learning model. Now, the first thing that we need to do is to load up our CSV file and specify the data that we're going to use to train our machine learning model. So to do that, we're going to create a new constant called data, and it's going to be initialized as a new instance of a ML data table. So this ML data table can be initialized from either a JSON data format or a CSV data format. And in our case, our data table is a CSV. So we're going to convert this CSV into a ML data table. And we'll do that by using the method contents of from a URL. And that URL is basically the location where our data exists. So let's go ahead and create it. So we'll just write URL and we'll initialize it using file URL with path. And that path has to be a string that represents the entire file path in order to get to this file that we want it to read. Now that is basically this down here. It's going to be at /users/AngelaU/downloads/TwitterSandersApple3.csv. Now, if you don't want to type all of that out and make sure that you don't make any mistakes, a neat trick is just to head over to terminal, type cd space, and then we can simply click and drag this file into here. And it'll automatically load up the entire file path that's required to reach that file from the root of our computer. So now I can highlight all of this and copy it and paste it in here as the string that I'm going to use to create a file URL to load up and convert into a ML data table. Now we get an error that tells us that the initialization of the ML data table can throw an error but is not marked with try. So that means that if when we try to convert a file to an ML data table, and actually this file isn't a CSV or a JSON, or even if this file plainly just doesn't exist, then we'll get an error. So we need to mark our initialization with a try. And if we don't have a file here and this fails, then we just don't want our code to continue. Now, the next thing we need to do is remember when we created our image recognition model, we had some training data and we had some testing data so that we could train our model up and then evaluate how good it is based on images that it had never seen before. Now, we have to do the same thing here with our Twitter sentiment analysis data. Now, you can either randomly go in here and pick out 20% of tweets, including their sentiment, and create a new table and load that in and save it and load it in and add it to our script. Or we can use a very simple method that just splits up our data randomly into 80% for training and 20% for testing. So the way to do that is to write let, and we're going to create two constants, one called training data, and the other is called testing data. And this is going to be equal to the data object that we already have, but split using a method called random split. And this is only available for CreateML. So we can't use this for just, anything that we want to do. It's specifically made so that it's easy to split up a data set to a 80% training data and 20% testing data set. Now, this method takes two parameters or two inputs. One is, how do you want the random split to be carried out? Do you want it 80-20? Do you want it 70-20? Then you just use a double. So for example, 0.8 to represent 80% training data, 20% testing data. If you wanted, say, 20% training data and 80% testing data, then you would just put 0.2. Now, the second parameter is a little bit more complex. It's something called a seed. And the seed relates to how random number generators work. Now, as we learned previously, random number generation using a computer is never truly random in the same way that it's random in nature. Now, in certain instances, if you want to be able to reproduce the randomness from a random number generator, you can use something called a seed. So, for example, we're currently splitting our data randomly to 80% and 20%. But if we need to reproduce this in the future to, say, debug our code or try to figure out why is it that our model isn't working, then we can use the same seed to generate the same random split. So in here, I'm just going to put 5. And in the future, if I need my data to be split randomly in exactly the same way, then I can simply use that 5 as the seed to achieve that. So now that we've split our data randomly, then we can go ahead and create a new instance of the ML text classifier. And this is going to create our machine learning model by passing in our training data. So let's call it sentiment classifier. And it's going to be equal to a ML text classifier. Now we're going to initialize this brand new text classifier by using the method down here, which takes 3 parameters. One is a ML data table of training data, which we created here by doing our 80-20 split. Next is the name of the text column, so the column inside that table that contains the text, and another one, which is the name of the column that contains the label, so whether if it was positive, neutral, or negative. And you notice that this method also throws. So in addition to writing the method, we also have to mark it with a try. Now, the part that we're going to use as the training data is going to be this constant that we created here. And this is a random 80% of our data that is loaded up from this location. So whatever it is that you called it over here, it has to match over here. Now, how do we figure out what is the name of the text column? Well, let's head back to our data set, our CSV, and you can see that right at the top, we've got a name for each column. The column for the text is just called text with a lowercase t, and the column for the labels is called class. So now we just have to put that in here as the string. So the text column is called text, and the label column is called class. So this line of code will train up our text classifier by using our training data. Now, once that's done, then this object, the sentiment classifier, is now our machine learning model. But before we're done, we should test it against our testing data to evaluate how accurate it is. So we can generate some evaluation metrics by using our sentiment classifier and calling the method evaluation on. And we're going to call it on a object of type ML data table, which is of course going to be our testing data over here. So here we're going to pass in our testing data set, and at this stage we will have evaluation metrics that we can then use to figure out the accuracy. And the accuracy, so let's call it evaluation accuracy. This can be derived by taking the evaluation metrics that we got and finding one of its properties called the classification error, which is the fraction of examples that were incorrectly labeled by this model. So this is going to be a double. So for example, if you had 90% that were incorrectly labeled, then this number will be 0.9. If you only had 10% that were incorrectly labeled, then it'll be 0.1. So we can then take 1.0 and subtract the error to get the accuracy, so the percentage that it got right, essentially. And then we can multiply this by 100 in order to get a percentage. Now, at this stage, we can already go ahead and click on the play button to see what we get as a result. So you can see that it did all of this in a very, very short period of time. And we end up with a evaluation accuracy of close to 70%. So this means that in an ideal world, we should really feed our model more data so we can get it close to 75 or 80%. But for our purposes, 70% is good enough. And we're going to go ahead and save our model so that we can use it inside our app. So first I'm going to generate some metadata, and I'm going to use the ML model metadata, and I'm going to initialize it with all of these things. So it'll have an author, we'll have a short description, it doesn't really need a license, but it'll have a version, which needs to be a string, so inside quotes 1.0, and there's also nothing additional I want to add, so I'm also going to delete that. So now that I've created my metadata, I'm going to go ahead and take my sentiment classifier and I'm going to write to a URL so that I can save it. And again, we're going to generate our URL by saying URL, file URL with path string. And the path that I'm going to use is everything up to here. So I'm going to place it inside the same folder that I had my initial data in, and I can locate it very easily. Now, after the last /, I'm going to put in the name that I want to give my model, and it's going to be a tweet sentiment classifier. And remember, you have to end this with .ml model as the file extension. And finally, again, this write method can throw, so we must mark it with a try. All right, so now that we've written the 2 lines of code that is going to give our sentiment classifier some metadata, as well as tell it where it should save it to, then we can go ahead and click the play button to run those 2 lines of code. And you can see that because this part is blue, when we press this play button, it's only going to start running the code from line 13 onwards, so we don't repeat the part that we've already run before. So let's go ahead and do that. And now if we go into our downloads folder, you can see there is our brand new tweet sentiment classifier.ml model. So we've now saved our model, but while we're still inside Playgrounds, let's test our sentiment classifier. And we can do that by using a method called prediction from a string. So the string is any sort of tweet that we might come across in the wild. Apple is a terrible company. And remember that again, we have to mark it with a try. And we're going to go ahead and click play to see what we get. So the output of this method was the label negative. So that's working pretty well. So now let's try it with a positive sounding tweet. Say something like, I just found the best restaurant ever, and it's at Duck and Waffle. So now let's try this. Most humans will realize is a very positive sounding tweet. And again, our classifier is working pretty well. Classified that as positive as well. Now the last one that I'm going to try is something that sounds a bit more neutral. So I'm going to type a tweet that I think sounds kind of neutral. Let's try, I think Coca-Cola ads are just okay. Okay, so let's run this and see what we get. And again, neutral. So our sentiment classifier is actually predicting pretty accurately based off these 3 lines of tweets that I've just come up with out of the blue. Now, one of the reasons why we have a much lower accuracy for our natural language processing model compared to our image classification model is that image classification has less ambiguity. If I see a picture of a giraffe, then I will label it as a picture of a giraffe, and I would expect my image recognition model to pick up that it's a picture of a giraffe. But with something like sentiment, whether if something is negative, positive, or neutral, then even if you show 2 people the same tweet, often they might come to different conclusions. Some people might read sarcasm, or some people might be more sensitive or interpret the tweet in a different way. So don't be too disheartened if your natural language models are a little bit less accurate when you run the training data on it compared to the image recognition. It's a very, very different task, and it's actually a much harder task for a machine to perform. And looking at our sample tweets, it's actually not doing such a bad job at all. So in the next lesson, we're going to be creating our Twitter Menti project. We're going to be adding our brand new sentiment classifying model to our Twitter Menti project, and we're going to continue building our app.